This is Lab 4 Oscillations by Nicholas Schweiker. Okay, starting off with the purpose, the goal of this lab is to compare the observed motion in the experimental data in Tracker to the theoretical data in the GlowScript code of a mass attached to a spring oscillating. And the overall results, just a brief preview, is the change in total energy of the system is 0, and then the predicted and observed data are relatively similar. So here are the relevant physics concepts. We have Newton's second law, net force equals mass times acceleration. That helps us convert between forces and energy with kinematics. And then we have the velocity update, position update, and then the spring force, which is just F equals kx, where x is the change in x from the starting length or the resting length of the spring. Another physics concept we have is the energy principle, which in this situation, the change in energy of the system due to work by the surroundings or exchange of thermal energy is 0. And energy is neither created nor destroyed and can only be transferred from one form to the other. And then the total change in energy in the system is equal to change in kinetic energy, change in gravitational potential energy, and change in spring potential energy. So those are the only three kinds of energy in the system. And then the system in this situation is the weight, the spring, and the earth. And then the surroundings is nothing. And because we don't have any surroundings, that means that there is no change in energy in the system. So there's conservation of energy. So here's the experimental setup with the tracker. The calibration stick is set to 0.75 meters. The origin is right where the weight was released. And then you can see in the picture all the circles from the auto tracking with the weights connected to the spring. And then off to the right, we have the graphs of X over time and Y over time. And then we also have the data table, which was then put into Excel to get the data to compare to the GlowScript code. So here's the code model setup. We found K, the spring constant, by timing the oscillation time with tracker and then solving for K. Other constants like L naught were given to us in the pre-lecture videos. Off to the right, the code is very simple. We define the mass and then define the initial position and velocity found from tracker. And below, we have starting time and delta t. And then below, we have gravity, the K we found from the oscillation equation, L naught, and then we define the spring equations just with the equations given. And then below, we calculate the energies using the energy equations and then also calculate total energy. So moving on to the loop, we set time to be less than 9.22 seconds to match tracker. First, we just define initial energies, and then we calculate the gravitational potential energy, which is just mg, and then force of spring, which is negative k times s times L hat. And then we calculate net force, and then using that net force, we do velocity update formula and then position update formula. And then we update the spring, L hat, and S. And then below, we calculate the energies and the delta K, delta UG, delta US, and all that stuff with the equation shown to the left. So here are the experimental versus theoretical results. Off to the left, you see the visual created by the GlowScript code with the spring, ball, and then the blue lines represent the path of the theoretical data. And then in the middle, we have the graphs, and on the top is X position versus time, and on the bottom is Y position versus time. And you can see that the model and experimental data are very similar. The red lines are the experimental data, and the blue lines are the tracker and model data. Potential errors are other forces like drag that are present but are not taken into account because the system is not truly closed. Could have used incorrect spring constant in the GlowScript, and then tracker errors like auto track, start position, and then the oscillation period calculations could have been slightly off. The answer to this question is yes, the energy principle is satisfied because change in energy is always 0. The graph shows this by showing change in kinetic, gravitational, and spring potential energy are all related to each other. Like as one increases, another decreases. So when K peaks, gravitational and spring potential are close to 0. And then when gravitational peaks, kinetic and spring potential are negative. When spring potential peaks, K and gravitational potential are negative, and then delta E always equals 0. So here are the comparison of oscillation periods. We went with the K found in the Y direction because when plugged into GlowScript, it was more accurate than just the X direction, or the average of 6.4. We calculated both the X and Y directions oscillation period by looking at the graph from Tracker, finding 4 cycles, and then we divided that by 4 to find t, rearranged the oscillation equation to isolate for k, the spring constant, and then plugged in that oscillation period to get the k's. So x direction got 5.9, y direction had 6.8. 6.8 was the most accurate, so we went with that.